The last piece of our solving equations is solving literal equations. And some of you are probably wondering, what is a literal equation? A literal equation is an equation where variables represent known values. For example, the most common one you see in science class is d equals r times t, where d represents distance, r represents rate, and t represents time. And now, while typically you will be given two of those three values and have to solve for the third, if you know how to solve a literal equation, it makes your life that much easier in the end because you'll have less work to do once you have the values. The most common one we see in math class is y equals mx plus b, where m is your slope, b is your y-intercept, and x and y are any x and y coordinate. That one you will see a lot next unit and in the coming unit, so be prepared to see that. So let's take a look at our first example. Our first example says to solve k equal to c plus 273 for c. Now, a lot of you are going, wow, there's two variables. I don't get it. What we're asking you to do is pretend that k is another number, which technically it is because these are known values. We want to get c by itself, which I see that right now c is being added by 273. I need to get that gone, so I'm going to subtract 273. But if I do it on the right hand side, I need to subtract 273 on the left. So when I do that on the right, these cancel, leaving me with the c that I want. And on the left hand side, k minus 273 we cannot combine because they don't have the same last name. They're not like terms. So we just leave them. K minus 273. And this actually is our final solution. It doesn't look very complete, but it is exactly what we are looking for. In our next example, we have x equals 5y, and we want to solve this for y. So I'm going to box in my y, and I see that y is being multiplied by 5. So to undo multiplying by 5, I need to divide both sides by 5. And in doing that, the 5's cancel on the right, leaving me with y. And on the left, I cannot take x and actually divide by 5 to get one value, so I will just leave it as x over 5. And that would be my solution. In this next example, we have 3m minus 7n equals 9. This one is probably the most complicated we've seen so far, although not too bad. We want to solve for m. And so as I look at this, I see that m is first being multiplied by 3, and then from it we're subtracting 7n. So when I do my U-turn, I see to undo minus 7n, I'm going to add 7n. And to undo multiplying by 3, we're going to divide by 3. So when we go ahead and do this, first I will add 7n on both sides, canceling on the left, leaving me with 3m. And on the right, I cannot combine 9 plus 7n, so I'm just going to write it out, but I'm going to put it in standard form, so 7n plus 9. Then, as my plan states, I am going to divide both sides by 3. On the left, that cancels those 3's. On the right, I'm dividing the entire thing by 3, not just one of the terms, because you have to incorporate everything. That gives me m equal to 7n plus 9 over 3. But if you remember back to Unit 1, we cannot just leave it like this. We need to take that 7n plus 9 all over 3 and butterfly it out. And if you're going, I don't remember how to do the butterfly method, you probably want to go back to Learning Target 6 from Unit 1 and refresh your memory because you will be expected to know how to do it. So when I do that, I get 7n over 3 plus 9 over 3. That 7n over 3 I cannot simplify, so I'm going to just pull that n out to the side and have 7/3 times n. But that 9 over 3 I can simplify because 9 divided by 3 is 3, giving me a final solution of m equal to 7/3 n plus 3. This last example, we have to solve v divided by w equal to 9 for w. And I've got this w and it's in the denominator, which makes it more difficult to solve for. I want to get it into the numerator, so the way I'm actually going to do this is to take my v over w equal to 9, and I'm actually going to multiply both sides by w, because what that will do, w over 1 on the left, the w's will cancel, leaving me with v. Now while I'm not solving for v, now I have 9w on the other side, and now my w's in the numerator, therefore I can go ahead and solve it. We cannot just divide by v because v is not in the denominator, and you would end up with, or when you do that, you still have the w in the denominator, which means that you would have 1 over w equal to your answer, which doesn't work. So now I see that w is being multiplied by 9. So I'm going to divide by 9 on both sides, and in doing so that cancels now on the right, leaving me with w, and on the left v over 9 I can't do anything with, so I'll leave it as v over 9, and that is my solution. Your job now is to try these two you try problems, complete your summary for tomorrow.